Section G, Quadratic Optimization. This is a process of finding the maximum or minimum value of a function. That is what optimization is. So think about what we know about a quadratic. If it's in standard form, we can find the vertex by using opposite of b over 2a. If a is a positive value, we know the graph opens up, and so we have a y value, so we'll be finding the minimum. If a is negative, the graph opens down, and so we'll be finding a maximum value. Example 1, find the maximum value or the minimum value of the following quadratic functions. Now when it says value, they're asking for the y coordinate of the vertex. So a, y is equal to x squared plus x minus 3. Let a equal 1, b is equal to 1, c is equal to negative 3. Since my a is 1 and 1 is greater than 0, I know my function is concave up. So if my function is concave up, I will be finding the minimum value. X is equal to opposite of b over 2a, substituting in 1 in place of b and 1 in place of a. I get my x value of the vertex is negative 1/2. To find the y value, go back to the original function, replace every x with negative 1/2. After simplifying this down, I find that y is equal to negative 13/4. So my conclusion is the minimum value of this quadratic is negative 13/4. And this occurs when x is equal to negative 1/2. Example B, y is equal to 3 plus 3x minus 2x squared. So I'm going to rewrite this in standard form. Identify my a is equal to negative 2, my b is equal to 3, and my c is equal to 3. Since a is negative 2 and a is less than 0, my graph is concave down. Therefore, I will be finding a maximum value. X is equal to opposite of b over 2a. Substituting in my b and the a. Simplifying down, I end up with x is equal to 3/4. Go back to my original equation, replace 3/4 in place of every x, and simplify down. Y is equal to 33/8. So, the maximum value of y is 33/8, occurring when x is 3/4. Example 2. A garden has 40 meters of fencing enclosed a rectangular garden plot, which one side of the box, existing box, suppose that 2 new sides are x length. Okay, so I got this is x, so the other side is x. And then if I have a total of 40, this side must be 40 minus the 2 x's I've already used. Show that the area enclosed is this formula. So let's recall how to find the area of a rectangle, and also let's label some measurements here. So we used a variable, so we need to identify what it means. So we'll let x equal, the 2 equal parallel sides in meters. We'll let 40 minus 2x equal the side parallel to the brick wall. And I know finding the area of a rectangle is length times width. So my area here will be x times 40 minus 2x. And my units of measurement, this length is in meters, width is in meters, this must be meters squared. I've completed part A. Section B, find the dimensions of the garden of maximum area. So if I want maximum area, I'm going to multiply by the x. And now I have this quadratic equation. I'm going to find my vertex. So that's x is equal to opposite of b over 2a. So identify my a, my b, and my c. Plug it in to opposite of b over 2a. Simplify down. We get x is equal to 10. That's just to find the dimensions. X is equal to the width of our rectangular. So to find our length of our rectangle, we're going to do 40 minus 2x. So that would be 40 minus 2 times 10, replacing the x with 10, simplifying down, and I get 20. So my answer would be the dimensions of the garden with maximum area would be 10 by 20 meters. 10 meters by 20 meters.